Hi, I'm Tom Cherryhams with the FujiNet project, and I actually took and uncovered and put back together a copy of Compuserve Videotex for the Atari, and I'm trying to do a little demonstration here just to show how it actually worked. But before we do that, let's talk a few moments about what Videotex actually was. Well, Videotex was actually part of a wider range of standards, attempts at certain things to try and take and bring online services into the home. And there were a lot of these different standards. There was, CFAX in the UK, there was Minitel in France, and there were a number of Videotex services that were being launched in the US, such as Teledon and Cube, and the one that was a partnership between Motorola and Tandy, essentially became known as Videotex. And it was also adopted by Compuserve as a method of output as well. But it actually had its roots a lot earlier in the process, because before it ever was something that home computers could use, the original idea was that you just bought a cheap, inexpensive terminal to take and connect to your television set and to the telephone line and access these particular services directly. And if you really want to take and dig into this, there's a wonderful site here called tandyvideotex.com. I will take and put a link in the description so you can see it. And it goes through the history of this particular partnership between Tandy and Motorola and eventually Compuserve. The process of going through and building these initial ideas were these simple terminals, part of Project Green Thumb, which was initially a project to take and bring an information service to farmers. Ironically, the same idea that Minitel was having over in France. So they had this idea of a very simplified terminal here, you can see right here, with just a keypad and a television set and connecting to the telephone, power supply, etc. And we have a basic block diagram. And if you look at the block diagram for a few moments here and take all of this in, you'll see that this actually converged into something that we saw much later, both as the Videotex terminal and as the AgVision terminal, and eventually the TRS-80 color computer. So many of the concepts and the architectural decisions that drove Videotex's design were driven entirely by this reference design, which was used by the Videotex terminals, by the TRS-80 color computer, by the Dragon computers in the UK, and the smaller machines like the MC10 and the Matra Alice, and etc. There were, this reference design was used all over the place. So you see it eventually evolved from Green Thumb, became the Videotex terminal here. If you guys are familiar with the color computer, it looks like a color computer here. The difference is there's a phone jack coming out the back for the modem. The modem was removed after the AgVision project came and went, and ultimately we got the TRS-80 color computer and its descendants. And even for those, there was a Videotex cartridge which put the same software that was in the Videotex terminal back into the color computer. So you could attach a modem, you could use the Videotex cartridge and access the Videotex services. Now, this also goes into some of the detail about the head-end hardware that was used to take and multiplex all the incoming connections and to provide the content back. These custom machines, basically Tandy 6000s with lots of custom hardware running Xenix and the like. And even the software that these guys have managed to take and recover so that they can bring the service back to life. And this is still very much an ongoing process, and I'm very interested to see where this winds up. But if we actually take a look too, there are even articles that have been preserved showing a lot about the service, what it is, and how it was presented to the general public, as well as teaching courses that were ultimately going to use it. Of course, Compuserve adopted it and heavily promoted it in its magazines here, and so on. But one of the nice things that has come out of this particular project is that there is a demonstration server that can be run that ultimately, if I can take and bring it up here, I will take and reload it here, that shows some of the capabilities of this particular Videotex terminal, and this is ultimately what I'm going to run right here so you guys can see how this works. So for that, we have this running right here, and we'll go over to my main scene. Let's see here. Oop. Yep. And we will go and over to apps, which is my server, of course. We can take and go to Atari 8-bit. And we can go to comms, and you'll see there's a new entry in here for VIDTEX. If you want to take and run this demonstration server, you can get a copy here. For various reasons, I can't run it on my public system. Most notably, my version of Python on that system is too old, and I'm not ready to upgrade everything yet. We'll take and mount this read-only. We'll take and go into option here and load it. Now you'll see here, this program uses its own custom handler, which loads the 850 stuff all by itself. But we can see once it's up, we have a little sign-on screen here. And this was Compuserve's Videotex terminal that was intended to be used with the Compuserve information service. One of the things that happens whenever you connect to a system that can do Videotex is that it will ask for what type of terminal are you, and this particular terminal will respond back with a string of information. Let me go ahead, and I have to take and actually kick this thing a little bit, but it will go into terminal mode. There we go. And you'll see that there's a slight latency when I type here, and that's because there is automatic wrapping code working in the background here to automatically wrap text as it goes across the screen. And we'll see that in just a moment. But we'll go ahead and load this in here. I will connect to my service that's sitting on my development system here. By default, it opens up a port at 65432, and we'll take and connect to it. And yes, the only bit rate that we have here is 300 bits per second. It's kind of funny, but we'll go ahead and I will hit return a couple of times here. And you'll see that, look at what's happened here. You'll see that we have a terminal code here, and the terminal code identifies the type of machine that we are here, this Atari here. You'll see the first part of the code is the terminal type Atari, version 0. It supports, and then a list of all the things that it supports. Smooth scrolling, HC, and you'll see 24 and 40 here, and this indicates 24 lines, 40 columns of text. Now, by default, the standard Videotex terminal is actually 32 columns of 16 lines of text, but you can specify this here, and your terminal, if it parses it, can deal with it accordingly. This particular demo server doesn't really do much of anything with this terminal type here at all. But these are the types of things that it can support. Now, of course, we can do things like print the basic text, and this basically is here to show the word wrapping feature here. And we'll do, let's say, 100 words or so. And you can see right here, very carefully, as the text gets across here, it takes and wraps over to the next line. Tries to keep everything nice and neat so it prints rather nicely on the screen. And this was part of the Videotex standard. It was required. Let this take and finish up. Press enter to continue. And of course, we come back to the main menu here. And the next piece that we're going to do here is what's called Semigraphics. Now, this is character set graphics, but Videotex had a special form of character sets here. And as a matter of fact, I'm going to pause the video here so I can take and show what that character set actually looked like. Just a second. Up on the upper right-hand side of the screen, I've posted a picture here of the Semigraphics character set. And this is the character set that was typically run from the 6847's character generator that was in the 6847 itself. You'll see that we have two sets of alphanumeric characters up top, one for inverse video and the other for standard video here. But you'll also see that there are 8 sets of what are called Semigraphics characters. This is running in Semigraphics mode number 4, and that basically means that you have 4 potential positions where a dot can be placed for a number of combinations of characters here. And this was, ironically, on the Videotex terminal, on the color computer, on all of its descendants. This was where most of the color in the color computer could actually be placed, because you couldn't do this in text, and the graphics modes really didn't have support for color in the graphics, much color in the graphics modes. The most you could probably get was 4 colors in 2 palettes in the bitmap graphics modes. But this is Semigraphics, which gave you access to all of the 8 possible colors here. And you would use these characters to take and build low resolution graphics, albeit colorful. But we'll go ahead and show how the Atari takes and renders this out. We'll take and do Semigraphics here, and we will render, I don't know, 100 squares or so. And yes, it's actually using a character set, and it's using the artifacted output of mode 2 here to take and generate at least some color with the graphics character sets. So even though you don't get all 8 colors that are present on the 6847 here, you still get some color. And finally, I'm not going to show the stored text or the load and run executable aspects of this because, well, load and run is, I don't have anything for stored text, and load and run basically tries to run 6809 code, which can't run on this 6502 based machine. But yes, Videotex actually did have support for loading and running local code. Maybe something could be interesting could be made out of that. But we'll go ahead and do medium resolution graphics instead. And this demo server that Tim Lindner had actually put together, again, link is in the description, allows you to take and you can put a set of JPEG files in with it, and it will use Python's IM library to basically take and grab the black and white channel out of the graphic, and then basically apply a clamp. The image is resized to 128 by 96. It is then taken and turned into a monochrome 1-bit image and then plotted using the medium resolution 128 by 96 mode. We'll actually use graphic number 3 here to demonstrate a particular point here. I'm going to take and pull that image off the top here, and I'm going to replace it with the zebra that we're going to render here so you can see what's actually going to come out here. And I'm choosing this particular graphic to demonstrate its particular point. You'll see that the graphic actually comes across, even at 300 baud, the top portions of the graphic, which are mostly blank, are coming across very quickly. And this is because the graphics that are rendered here are actually being transmitted using run length encoding, which means that contiguous sets of pixels are encoded as a small set of bytes rather than taking and encoding each individual pixel, allowing for the image to be transferred faster. This was actually a forerunner of the RLE format that was prevalent in the early days of, in the early 80s or so of Compuserve. But you can see right here that even at 300 bits per second, it's doing a pretty decent job of sending this particular image across. We'll go ahead and let this finish. Once this finishes, it will take and just simply turn back to text mode. See? So there you go. As you can see here, this Videotex terminal actually implements the vast majority bits of Videotex and is quite usable. And, well, you know, maybe this actually proves that some sort of common standard could be made between all these various machines to take and do something interesting. Don't know. We have a demonstration server, so we know how these things work, and it's documented now. So maybe we could make something out of it. I'll go ahead and hit 6 to log out, and we'll be presented with no carrier. And that ends the demonstration. I hope you guys actually enjoyed this, and until next time, guys, have fun.